We're about to take a journey through the new capabilities offered in the VMware Cloud Director version 10.3.2, looking at key market drivers pointing to some excellent opportunities that are ripe for cloud providers to harvest. First, let's look at why Cloud Director is winning, and over 1,500 partners are actively delivering valuable and profitable cloud services to their customers. In the last 2 years or so, we've seen a significant expansion of capabilities where everything is offered as a service. From infrastructure, networking, security, data protection, containers, monitoring and management, as well as storage as a service, Cloud Director has you and your customers covered, with a diverse portfolio of differentiated capabilities not seen on any other platform outside of hyperscale providers. Cloud Director is now delivered as a VMware-validated design, which serves as a blueprint for your software-defined data center, SDDC, through a family of solutions that span applications, compute, storage, networking, and management. Cloud Director is now also supported with Cloud Provider Lifecycle Management. This helps remove variability between ESXi hosts by enforcing VMware application consistency across ESXi hosts in a cluster using a declarative model. This capability enables more efficient upgrades, improved reliability and performance, and easier maintenance. Cloud Director is also offered as a SaaS solution and on hyperscale providers with an architecture to broaden the delivery options, supporting VMware Cloud on AWS today and soon to support multiple other hyperscale providers. This new release is also relevant and compatible with the latest releases of NSX-T and NSX Advanced Load Balancer and core SDDC components of vSphere and vSAN. This new release of Cloud Director comes bundled in the Flex Core model with NSX-T, NSX Advanced Load Balancer, vRealize Tenant App, Cloud Director Availability Migration, and Log Insight. Cloud Director is now extended free of charge with the Application Launchpad, delivering VMware Cloud Marketplace applications from Bitnami and other third-party app providers, as well as custom apps, expanding the already rich ecosystem of solutions and services designed and tested to run on VMware-based clouds. Cloud Director is also delivered with Tanzu Container Application Framework, covering Kubernetes Container Cluster Services support, extended with Bitnami Dev-Ready Cloud applications. In general, 10.3.2 covers three main themes. NVIDIA GPU service is driving multi-tenanted GPU as a service, differentiating cloud provider capabilities for high-level compute services. Networking improvements removing blockers to adopt NSX-T and driving more service adoption with capabilities like edge quality of service. And lastly, operation automation improvements with an updated vRealize orchestrator and NSX-T workflows. Let's take a moment to explore the graphics processing unit, GPU, market and its impact on the future of supercomputing. The GPU market is a highly fast-growing market. The expected growth, and hence the opportunity, are massive. We can expect to see it grow at a CAGR of 33.6% from 2020 to 2027. The drive behind this growth is that GPU is essential in many high-growth areas, not just virtual desktop services, but especially artificial intelligence and machine learning. This connected growth is due primarily to the increased capacity for the high-performance processing required by these other technologies and related innovations. As one example, with a parallel structure, they're more efficient than general-purpose central processing units, CPUs, for algorithms that process large blocks of data in parallel. Of course, AI and ML are reliant on large data volumes to learn, and we expect this trend of GPU services to grow. This is something we could have typically found in hyperscale. Still, it's now vital in the data center and highly relevant to sovereign clouds and other situations where data must remain resident in country. These images highlight the main differences between the CPU on the left and the GPU on the right. The CPU is composed of just a few core arithmetic logic units, ALUs, with lots of cache memory that can handle a few sequential threads at a time. They are concurrency limited and need to queue more work in cache for processing. A CPU is a generic worker able to handle a wide range of tasks requiring lots of interactivity. One example is calling up information from a hard drive in response to a user's keystrokes. In contrast, a GPU comprises hundreds of cores that can handle thousands of threads simultaneously. This is good for parallel processing, executing thousands of operations and problems simultaneously. GPUs perform much more work for every unit of energy than CPUs. In AI, GPUs have become key to a technology called deep learning. Deep learning pours vast quantities of data through neural networks, training them to perform tasks too complicated for any human coder to describe. With support for a fast-growing number of standards, such as Kubernetes and Docker, applications can be tested on a low-cost vGPU and scaled out to faster, more sophisticated server GPUs, as well as every major cloud service provider. Many industries will use GPU services, and this will continue to expand as more and more businesses utilize AI and ML, as they also require processing on large volumes of data. GPU in finance addresses mobility and scalability challenges in investment banking, trading and retail, and insurance. Graphic acceleration on desktops, mobility on trade floors, multi-monitor app usage are core requirements in this sector, each of which GPU addresses. GPU in healthcare has several scenarios where GPUs offer many benefits. They're ideal for imaging tasks, of course, but GPU-based deep learning speeds the analysis of those images. They can crunch medical data and help turn it into new healthcare delivery capabilities through deep learning. GPUs can also help deliver essential cost reduction and improved care, enabling solutions across nurses' stations, doctors' offices, doctors' tablets, medical research data AI and ML, and patient record applications. GPU in manufacturing uses AI and ML to enable rapid modeling and analysis innovations in product data management, product lifecycle management, manufacturing floor, job site, and support. In the automotive manufacturing industry specifically, GPUs offer many benefits. For example, they provide unmatched image recognition capabilities, as you would expect. They're also vital in creating self-driving vehicles able to learn from and adapt to a vast number of different real-world scenarios. In manufacturing robotics, as another example, GPUs are crucial to enabling machines to perceive their environment. However, their AI capabilities have become key to machines that can learn complex tasks, such as navigating autonomously. GPU in government can leverage GPU services to increase security, improve mobility, and lower maintenance costs. Design and engineering in the public sector, with complicated datasets and graphic-intensive apps delivered over VDI, simulation and training and geospatial research as two examples, also benefit from PGU services. GPU in media delivers the GPU-accelerated virtualization of artificial intelligence, AI, and high-performance computing, HPC, workloads. GPU in education is a sector where designers and engineers learn with new graphics-intensive software, and data scientists and analysts run computationally intensive workloads. GPUs have become essential for all of these activities. The introduction of GPUs in this sector began by accelerating gaming and graphics. Now they're accelerating more and more areas where computing horsepower will make a huge difference. GPU as a service is a key growth area for GPU services. We see an ever-increasing number of data centers because of ongoing digitalization across several industry verticals, adopting predictive analytics tools and other services that only GPUs can support. This is creating more business opportunities for GPU as a service consumption. Typically, AI and ML applications would require high-performance computers fitted with upgraded GPUs. However, the advent of GPU as a service in Cloud Director allows customers to use the processing power of GPUs by leveraging cloud technology without the need to purchase high-end GPU hardware themselves. Such services can be offered based on pay-per-subscription, which makes it very cost-effective. The bottom line is that GPU as a service is an important opportunity for cloud providers. We've built this capability right into Cloud Director, where we can offer not only GPU as a service, but also multi-tenanted GPU as a service, allowing cloud providers to gain more margin in their GPU service than any other solution. We take advantage of NVIDIA MIG multi-instance GPU, which achieves multi-tenancy boundaries between workloads at the physical level inside a single device and generates better optimization of hardware and more margin. As this high-level diagram shows, GPU as a service relies on features available in vSphere 7.0, hardware version 17, such as assignable hardware, GPU profiles, and NVIDIA-compatible GPU hardware. Each VM gets GPU pass-through via NVIDIA, technology which virtualizes the GPU, allowing multiple VMs to share the same GPU, a virtual GPU. NVIDIA must be installed on ESX, and the NVIDIA licensing is something the cloud provider manages separately. This also means that tenants can run Tanzu containerized applications for machine learning and deep learning in the VCD environment to isolate workloads and securely support multiple users. Tenants can harness the power of multiple vGPUs in a single VM to scale application performance, a critical element for deep learning training workloads. Finally, tenants can use the relevant VMware Marketplace applications we noted earlier to avail of AI/ML capabilities through offerings such as TensorFlow, MXNet, dcube, Cognitive Assistance, and Dask Parallel Computing. Providers will offer vApp templates pre-configured with all the necessary sizing policies, placement policies, GPU profiles assigned, VM and guest OS enabled for GPU. GPU as a service consumption is a growth area cloud providers should notice, specifically as it relates to offering solutions for GPU consumption management, monitoring, and metering. Cloud provider tenants on Cloud Director can create a new VM from a GPU-enabled template with access to GPU, and, if the target hardware supports it, can vMotion a VM and resume GPU-enabled VMs on the same or another host. Cloud providers and tenants are able to monitor vGPU consumption per tenant in the RAM and CPU dashboard and tenant UI, and cloud providers can gain access to metering information via API for vGPU consumption per tenant for tenant billing. Let's take a closer look at the networking updates in Cloud Director 10.3.2. New customized segment profiles enable providers and tenants to manage NSX-T segment profile templates and apply them to org VDC networks, vApp networks, and VDC group networks. These custom segment profiles are needed in several specific situations, including, but not limited to, MAC or IP learning needs to be enabled for nested environments, custom security profiles to allow for DHCP traffic originating from a network, custom security profiles for HCX, enabling spoof guards, defining QoS on specific networks. When implemented, custom segment profiles deliver the ability to define a global org VDC network segment profile template that's to be used when any new org VDC network is created, define a global vApp network segment profile template to be used when any new vApp network is created, set org VDC network and vApp network segment profile templates at the org VDC level. This would override any global defaults. Set org VDC network segment profile template when creating an org VDC network. This would override any global or org VDC defaults. Manage org VDC network segment profiles from VCD directly. These are the profiles set in NSX directly. Customers need quality of service to ensure the performance of critical application meets their requirements even when there's limited network capacity. The primary goal of quality of service, QoS, is to manage packet loss and reduce latency and jitter on a network connection. Rate-limiting QoS through the Edge Gateway enables organizations to adjust their overall network traffic by prioritizing specific high-performance applications. More specifically, VMware Cloud Director, VCD, can now use a pre-configured QoS profile at the customer gateway for both ingress and egress in the API and UI. The QoS profiles can be designed simply and infrequently as an operational configuration or managed service in NSX-T. The more frequent workflow, creating profiles on an edge gateway where the bulk of the QoS profile specifications occur, can now be accomplished in VCD. VCD provides a simple mechanism for the provider and/or the tenant to specify the desired QoS profiles when configuring edge gateways. The QoS profiles must already exist on the target NSX-T manager for this to work. It's also assumed that configuring the QoS profiles is a day 2 operation or a managed service that the provider completes. In the context of the Edge Gateway, providers and tenants can specify both the QoS profiles for egress traffic and ingress traffic. The VCD code makes a call to the NSX-T to find all QoS profiles for that specific manager, allowing the provider or tenant to specify the desired profile to apply. Know that all components of this solution are protected by the same rights governing the ability to update properties of gateway. This is typically restricted to providers, but can be assigned to tenants also if required. Cloud Director now allows tenants to configure their NSX-T routed org-VDC networks as distributed, much the same way that NSX-V routed org-VDC networks could be configured with a distributed routing flag. For NSX-T org-VDC networks that are not distributed, VCD will attach this network to a Tier 1 CSP port, i.e. directly to the service router. This delivers the possibility for east-west security on the same edge. As an example, providers who want to use the Edge Gateway firewall capability to control east-west traffic. Before this 10.3.2 release, that was impossible to do, since east-west traffic was always distributed and bypassed the NSX-T service router node altogether. By forcing all east-west traffic between networks through the Edge Gateway, using the previously required and more expensive DFW solution is not necessary. This also helps unlock migration challenges from NSX-V to NSX-T. For all of this to matter, it must be developer-ready, as this is key for future applications on the Cloud Director platform. CSE 3.1.2 will be delivered imminently, an exciting step forward in the Kubernetes as a Service solution with Tanzu Kubernetes Grid capabilities. CSE 3.1.2 focuses on providing automated management capabilities or lifecycle management of TKGM clusters on Cloud Director. With the introduction of a cluster API provider for VMware Cloud Director, simply put with CAP-VCD, the cluster lifecycle management is greatly simplified as it allows the VCD users to manage, create, read, update and delete and upgrade using Kubernetes-style APIs and patterns to automate cluster lifecycle management on the Cloud Director platform. Another advantage of CAP-VCD is that it allows high availability for the control plane with multiple master configurations fronted with the NSX Advanced Load Balancer. This ensures better network performance while protecting clusters against a wide range of failure scenarios. With CAP-VCD, users will be able to create and manage TKGM clusters in one unified mechanism. This functionality also helps in offloading admins from performing non-trivial tasks across clusters at scale. Finally, CSE 3.1.2 offers global proxy support for TKGM-based clusters. In addition to being dev-ready, Cloud Director 10.3.2 has operational automation improvements. Cloud Director now supports vRealize Orchestrator versions 8.6, 8.5, and 8.4, and orchestration support for the Cloud Director REST API schema in 10.3.1, compiled to support the latest JRE JDK for Java version 11. This has been a long-awaited update for organizations that use the vRealize suite, enabling them to upgrade to the latest Cloud Director version. Support has also been supplied for basic NSX-T workflows, NSX-T Manager, Geneve Network Pools, NSX-T-backed Provider VDC, T0 Gateways, NSX-T-backed External Networks, and NSX-T-backed Edge Gateway. These limitations have been a previous blocker for some customers to advance to NSX-T, where automation is necessary to provision networking components via vRealize Orchestrator. Now, they can safely move forward with their migrations and innovations. We hope that this update brings value for our cloud providers, and thank you for our ongoing partnership.